Hey everybody, it's Mrs. Peachy from your WCA Marine Science class, and today we are going to be looking at a tutorial for your Unit 4 Lesson 4 portfolio on creating a phytoplankton. This is your final portfolio for first semester, and it's actually going to be one of the most creative portfolios that you'll be able to do for this school year, at least in my class. So what this portfolio does is talks to you a little bit about what phytoplankton are and how important they are in the food web of the ocean, really no matter where you go inside the ocean, whether that's in the Antarctic, in the coral reefs, or even out in the open ocean. Phytoplankton, remember, are photosynthetic plankton. So keep that in mind when you are designing your phytoplankton, that the phytoplankton needs to be able to do photosynthesis. Otherwise, it wouldn't be phytoplankton, it would be zooplankton. Some phytoplankton are microscopic, and others would be things that are macroscopic, larger, free-floating things like kelp or stuff like that. Many of the ones that you see here on this picture are microscopic phytoplankton, different shapes and different different colors and arrangements, but they have a lot of properties in common that allow them to be successful in their role as phytoplankton. Of course, one of which being that they do photosynthesis, which, remember, makes them phytoplankton. So what you're going to do here is you're going to design, build, and test your phytoplankton. You can actually make a model of a phytoplankton, although yours will not be tiny. You should make it, a scale model, a larger thing. You're scaling it up. And you're going to use household objects to design your phytoplankton. But remember, too, what a phytoplankton needs to be successful. So it's important that you kind of read this paragraph here, or this series of paragraphs here, to explain what important characteristics your phytoplankton would have. Okay, so remember that you are going to test the phytoplankton. You're going to be testing it both in air and in water. And you do have to actually design and build something. It's definitely not something where you're just going to take a household object and pretend that it's a phytoplankton. You have to design it, you have to build it, and carry out the experiment. It says this right away in the first part. Your model can be made out of anything, but you do need to build something. Taking a cotton ball or crumpling up a piece of paper does not count as building. The models need to sink, drop as slowly as possible, so you will want to use light materials. But also keep in mind that they do need to drop. And while all of them will drop in air because gravity, not all of them will drop in water because you have your buoyancy too to take into consideration, right? The model should be as realistic as possible with the exception of its size. You're going to provide a list of materials to explain what you build your phytoplankton out of, as also a paragraph explaining how you built it, and be specific. So if I wanted to follow the directions and build my own phytoplankton, it would look like yours. Take a picture of you and your model to send to me, either electronically as a separate document. Take a picture before testing the phytoplankton so it's not ruined. So every one of you should be turning in a picture to me of you posing with your phytoplankton. These are my favorite pictures of the year, so, don't mess with my joy. And then finally, you're going to talk about what your phytoplankton was like and why it either was or wasn't successful. The questions that it asks here is think about the environment where your phytoplankton will live and the needs that it will have. What shape will your phytoplankton model have? How large will your phytoplankton be? Obviously, your model is larger than it would be in real life, so tell me, how large would it be in real life? How heavy will it be? What structures will it have to affect its sinking rate? And what color would it be? Think not only about photosynthesis there, but also about camouflage and ways in which it can protect itself from predators. Maybe it has a color that helps to warn predators. Maybe it has a counter shading, so it helps to blend in when predators are viewing it from below. Now, when you come to test it, you're going to test it both in air and in water. In the air, you're going to drop your model from a chair, a step ladder. You could stand on top of a balcony on a staircase and drop it. So as long as you are dropping it from as high of a height as you can safely, okay? So don't be climbing on top of the roof and dropping it off. You want to make sure that this is a safe project. Use a stopwatch or a second hand of a clock to determine how long it takes the model to drop to the ground. It is helpful to have a partner for this so that somebody can actually observe it dropping and hitting the ground while you're dropping it. Okay? Make a data table to show that data. In the water, you are not going to be able to test it in a pool unless you work at the YMCA or something, or are fortunate enough to have an indoor pool, which I would imagine most of you do not. You can test it in the bathtub. That works out well. If you do not have a bathtub, you could use a large tub of water. This is something that it pays to plan ahead. So if you don't have a bathtub or some other larger kind of deeper water container, it would be better to build your scale model down and have it be smaller. Okay. The other thing to take into consideration is, basically how big you're going to make it, how much surface area it has. So if it has a slower sink rate because it's pretty buoyant but not buoyant enough that it stays floating, it's going to sink slower. It will be much easier for you to time it in a shallower body of water. Another option is you have a garbage can out in the garage or something. You can take that and fill it with water in the name of science. Tell your mom and dad, okay? That will work pretty well because usually those are a few feet deep. So you'll have some depth. You don't need a lot of area this way. You just need to have depth. You're going to repeat both the air trials and the water trials 5 times each. Put them in a data table and kind of use that information to answer the analysis questions. Did your model drop at the exact same rate each time? Yes, we know that the air dropped a lot faster than the water. That's not what we're talking about here. You're looking at all 5 trials of air and all 5 trials of water. Are they the same, the 5, within each category? And I can tell you right now they won't be the same. So you need to figure out what factors affected the fall rate. Okay, so what things made it either faster or slower? Those are some things to take into consideration. That's question number 2. Question number 3, what would cause differences in sinking rates in the ocean? Don't just think of the phytoplankton itself. Now think of external factors too. What other factors within the ocean could cause the phytoplankton to sink at different rates at different times? Would you say that you've designed a successful phytoplankton? Why or why not? And what would you change if you could design it again to make it more successful? All right, so that information, you need to have not just your analysis questions, remember, but you need to have your kind of your beginning questions here, these questions. You need to have your data table, there's 2 of them, and you need to have your final analysis questions plus your picture with your phytoplankton. Yes, your picture with your phytoplankton. I can hang it up on my wall and turn that into me. If you have any questions or concerns, feel free to give me a call at extension 2204, or you can send me a webmail message. Have a good day, everybody, and good luck with your portfolio.